Okay, so in this video we're looking at open-ended manometer problems. So if we have an open-ended manometer which contains mercury, it's attached to different flasks with gases in order to measure their pressure. So we're going to take a gas in a flask, attach it to the manometer, look at the change in the mercury and use that to find the pressure. Okay, so we're going to be given the atmospheric pressure, measurement of the column for each, and we have to sketch it and give the pressure. So there's two different scenarios we're going to solve here. A, the barometer is 755 millimeters mercury, and the manometer measured 54 millimeters higher on the arm open to the atmosphere, so this is pushing the gas back up against the atmosphere. And in B, it's 100 millimeters higher on the arm open to the gas, so it's pushing back the other way. So let's take a look at A first. So where you deal with this situation, and the first thing we're going to do is draw this manometer. So as you can see right here, when we draw the manometer, we're going to have the gas flask attached down here. This is our mercury column. The height, if you notice, is higher on the right because this is the open end to the atmosphere. And that means that what we're looking at is a situation where this gas is pushing down on that, and the height of the mercury is pushing down, as is the pressure of the atmosphere. Therefore, if we were trying to write out this equation, what we're really looking at is a situation where the pressure of the gas is offset by the pressure of that mercury column and the pressure of the atmosphere together. Okay, or if we were to write it out a different way, it would look like this. The pressure of gas is equal to the pressure of the atmosphere plus the height of the mercury. So given that we know that this is the equation we're dealing with right here, and this is the setup, we can go ahead and plug in the values and solve it. So we are looking for the pressure of the gas. We know that that is equal to the pressure of the atmosphere, which is 755 millimeters of mercury. And that we're going to add to the height of the mercury, which we know is 54 millimeters, so that's clearly in millimeters of mercury, since it is actually measured as millimeters of mercury here. And so we can add the two of those together, and we get 809 millimeters of mercury. The answer, however, we want to give is in atmospheres, so all we're going to do is simply convert that, 1 atmosphere over 760 millimeters of mercury, and therefore our answer for the pressure of the gas is going to be 1.06 atmospheres. Okay, let's take a look at the other setup. So in part B here, the barometer is 759 millimeters of mercury, so that's our atmospheric pressure, and the manometer measured 100 millimeters higher on the arm open to the gas. So this is a sort of different situation than one we had before. So when we go to draw the mercury up higher on the side with the gas. Okay, now in order to set this up, if you visualize, really everything on the left side of this U-bend pushing down is going to be opposed by all the forces on the right. So in this case we have pressure of the atmosphere on the right, and on the left we have the pressure of the gas pushing down, and we have this difference of height in mercury. Okay, so if we were to write this one out as an equation, okay, we have the gas and the mercury together offsetting the atmosphere. Or you can write the pressure of the gas is equal to the pressure of the atmosphere minus the height of the mercury. Okay, I just simply moved it. You could also say pressure gas plus height mercury equals pressure atmosphere, but simply moved it to the other side here and subtracted it. All right, so in this case, we are starting with the equation where we have to have the pressure of the gas. It's going to be equal to that 759 millimeters of mercury. And from there, that is going to have to subtract 100 millimeters of mercury. Now note, if this came to us in centimeters or something like that, like some of the problems will, you're just going to have to convert that to millimeters, and that will then let you figure it out just fine. So that right there is going to equal to 659 millimeters of mercury. And the 659 millimeters of mercury, we need to convert that into atmospheres by doing the same way that we did before, 1 atmosphere over 760 millimeters of mercury. Okay, the answer we get here is going to be 0.867 atmospheres. So that's how you deal with a open-ended barometer in the sort of two situations you'd hit, where the gas was either higher pressure than the atmosphere, and therefore the mercury column was higher on the arm open in the atmosphere, or the gas pressure is slightly lower than the atmosphere, in which case the mercury will be pushed back towards the gas.